All right, welcome everyone to the June 17th Arborist call. Similar format as always, quick welcome and intro. Then if there are any status updates, we kind of do those as needed on the node implementations that are currently in development, ZBRD, Zcashd. If we don't have anything specific to cover there, we just pop over those and go to the kind of the core of the call, which are just discussions related to protocol development. In this case, we'll just kind of walk through an NU5 update, and then I'm sure we'll have plenty of time for any other topics that might come up, or we can do a deeper dive on NU5 as well. And then we just have a wrap up. Before we get going, I want to say a huge congratulations to everyone involved in ZCon 2. Dodger, you've been at ZCons in the past. This was your first ZCon in your role at the foundation. I know you had a lot of help, like Danica did a great job, Paige did a great job.
Yeah, I want to make it clear that I had very little to do with the schedule was pretty much already set. You know, everything was. I just took the praise.
You just showed up when they said show up, right?
Exactly.
But I know Ryan Taylor did a lot of great work with like sound checks and the voice and video quality checks ahead of time. So a ton of work went in before it ever started. It's my first ZCon. I haven't. There hasn't been one since I joined the company because because pandemic last year. But I thought it was excellent. Like I had it up the whole time. So I think it was incredibly well done. Timings were great. As a speaker, I felt really prepped, like I knew what I needed to do, where I needed to show up, at what time and everything. So just huge congratulations. I know a number of people on this call had at least one, if not multiple presentations. So congratulations to everyone here that also spoke and made it a success.
If you thought that was impressive, you should see an in-person ZCon. But yes, it went very smoothly.
Yeah, I'm really looking forward to it. I mean, I've heard Montreal and Croatia, and we were trying to go to Lima last year, and so I'm really looking forward. I'm hoping that the next one, the world has settled down and it can be in person. That would be incredible. So anyway, again, huge kudos to everyone involved and everyone that presented there. So moving on, what are Arborist calls? Bi-weekly calls where the protocol contributors get together to talk about timelines, R&D efforts, design, implementation issues, new features, blockers, unresolved issues. So all things protocol, essentially. Who can participate? Anyone that's interested in protocol development. The more the merrier, actually. If there's something that you'd like presented or talked about or discussed, and maybe you don't have the background to lead that discussion, suggest it as a topic and we'll get it slotted in. We can talk about it and make sure that we get everything covered. That's my email address. You can reach out to me there. I'm also in the R&D Discord. You can get me in that Discord and just let me know, that you'd like to present or request a slot or suggest a topic for us to dig into a little bit deeper. That'd be awesome. So research and implementation updates. Anything on the ZBRD side? Any highlights wanted to point out or cover this week?
Yeah, we
go ahead, Tior.
Oh, sorry. Yeah, we continue to work on verification for NU5 and previous network upgrades. We're now getting to the stage where the number of verification tickets we have remaining is 10 or so. So I think we're doing pretty well, maybe 10 or 20. And we're continuing to fix security issues and issues where Zebra hasn't been a good network participant. Most recently, we've put some rate limits on our outbound connections and some of our outbound messages. And also we've fixed up our handling of the last seen times for the peers that we gossip. So those are now accurate rather than being all over the place. So I think those would be some of the big ones. I think Deirdre wants to talk about something else though.
So getting reviewed and looks to be merged in a few days is a batch verification of Red Palace signatures. So those are the spend auth and binding signatures for Orchard transactions. a very straightforward port of the batch, the variable time multiscalar arithmetic and batch support for that, for using that arithmetic from what we did for Red Jub Jub to Red Palace. The major change is instead of using a projective Niels intermediate representation to do the math over for the Edwards curves, it's just using the regular projective form for the short Weierstrass curves. I tried it and it was almost more than 5 times faster than doing them independently when using that. And I was like, sounds good to me. And then all the tests passed. So that is getting merged in, and that is internal to the Zebra chain crate. But whenever we kind of finalize our consolidation of how we want to do Red DSA or just Red Jub Jub or Red Palace or whatever it is, we can share that upstream wherever we want to put it. It's really fast. It's great.
I think the nearest equivalent to extended Niels for short Weierstrass curves would be Chudnovsky coordinates.
Oh,
but I'm not sure that they're actually much faster for this use.
yeah, I've not heard of them or used them, and the regular schmegular projective was quite fast. So I think I'll leave it.
Chudnovsky is where you cache C squared and C cubed.
Ah, cool. Thank you.
But you should only obviously do that when you need to, because otherwise you have more work for you.
Yeah. That's the major thing for now this week.
Cool. All right, very good. On the Zcashd side, I mean, obviously our focus is exclusively on NU5. We did put out a point release 4.4.1, had a few locking fixes in it, but mainly we had 4.0.4.3.0 was EOS halting on the 16th. And we like to have 2 releases in the field that support any given network upgrade. So we dropped a point release to have that available. So that's kind of the only thing Zcashd specific beyond, again, NU5, which we're about to talk about in a little more detail. Speaking of NU5, feature set, which everyone is intimately familiar with. I kind of put it in here just in case someone comes into a random Arborist call and hasn't followed the progression of what we're talking about and what's in NU5. So that's the list. Zip 32, Zip 221 were existing zips that were updated to reflect some changes for NU5, and then the remaining zips are new. 252 is largely just kind of a deployment zip, kind of covers consensus branch ID, things of that nature. So.
Yeah, I think the only relevant thing for that is that we've just clarified this week that the orchard pool is going to behave the same way as Zip 209 implemented for the sprout and sapling pools, i.e. if the pool balance goes negative, that's a consensus violation. And so that was sort of implicit in Zip 224, but it was easier just to update Zip 209 to make it clear so it's a single place that everyone sees those, which fits
Strad got there before me. I was going to make the same.
Okay. I need to update my list. I'll just add it.
It's on the front page of zips.z.cache. So that's that's the single point of truth if you want to know the set of zips for NU5.
I have a question.
Go ahead, Nate.
The Zip 221 is new to me. Can anyone summarize it?
That is the fly client zip. So that's history trees. We had, so when this was the one that was deployed in Heartwood, and when we deployed it, it was and it was ordered and things. But the design of it was such that you could. It started a new tree at every network upgrade, which means you could change the data that was committed to in the tree on a network upgrade boundary. The existing tree commits to the sapling commitment tree, node commitment tree at each block, and the number of sapling transactions. We've just made a simple delta on the format to add in orchard into those commitments, so that like clients can commit to those trees in the same way they could commit to sapling.
Awesome, thank you.
So that's literally the only change. Everything else is identical.
All right, very good. Okay, any other questions about the zips content, comments on anything that might be relevant to point out. Zip 209 is a great one to bring out, Strat. Okay.
Yeah. So there's a clarification to, was it Zip 244?
Yeah.
About how the authorizing data tree structure. So it wasn't exactly clear how that was extended to a perfect binary tree and how pre-V5 transactions were handled in that tree, but that's been clarified now.
Okay. All right, very good. The audit schedule, again, as a refresher, we're in the throes of the implementation audits. CEDIT started on the 7th of June, runs through the 8th of July. NCC started Monday, runs through the 1st of July. Essentially, so we're in the middle of the implementation audits. Again, just for reference, we'll see this on the next slide. The specification audits have already occurred. So the feedback from that's been incorporated into typos in the zips or the spec or whatever was appropriate at that point. So if we look overall kind of at our schedule, one of the things Deirdre and I talked about in reworking the NUP, and we kind of mentioned it last week, was kind of going toward, especially as we were in a little broader strokes looking at network upgrade timelines, that we would have kind of target activation windows for when testnet and mainnet would activate. We're, as I mentioned, in the middle of our implementation audits, which as they currently stand, wrap up July 8th. We want to make sure that we have enough time to cover everything in those audits. It's quite a bit of code change. Currently, they wrap up July 8th is the latest. And given that schedule, we're looking at a testnet activation window roughly the latter part of July. And I'll caveat all that with, subject and dependent upon our ability to get code reviewed and merged and the outcome of the audits. But that's roughly kind of what we're looking at on the testnet side. And then again, if you just fast forward 3 months roughly, so that we've got an adequate partner adoption period, you're kind of looking at, a 3-month fast forward and a 2-week activation window for mainnet in the latter half of October. Again, to be determined. If partner adoption goes, super smooth and everybody's ready, we could always look at activating a little earlier if we wanted to, but we don't necessarily have to do that. So Dodger, I think your hand just went up. I hid the participants for a minute, but yeah.
Yeah, just on that note, I just wonder if there's an update on how the whole unified addresses thing is going.
Mm-hmm. So, I mean, I'll let the team speak to the implementation specific things. So what our plan, is this is going to be a pretty heavy lift on the partner adoption side, more so than like a typical network upgrade. Like we're doing Shielded Coinbase and Fly Client. It's like, just kind of check, did you get the right release activated? That's kind of about all you had to do. In the case of NU5, unified addresses, it's a much higher touch kind of network upgrade in terms of partners. So the month after testnet activation is kind of a period of time where we've committed internally to have all the library support we needed for the wallet team, which is in turn for wallet vendors to use, the Nighthawks and Unstoppables. And we've been working with the DT at Zec wallet, obviously, really closely, and those others as well as we go. So the library support will be nailed down in the first month after testnet activates, and then we'll also work with other partner types during that time. Gemini in particular, we've already had a kickoff call with to go over the basics of unified addresses, and based on our knowledge of their implementation for Sapling, what that would look like on their side, and rough approximation of the changes they would need to make. We'll continue to follow up with them, and then on the mining side, it's a much lower lift in terms of changes for NU5 and unified addresses, but that's kind of the high level strategy, if you will. And if obviously any members of the team have some additional info they want to provide on that, that'd be great too. But
yeah, I mean, as far as the as far as the implementation side goes, the Rust logic for handling all that is in. There's some connective tissue that still needs to be added to bring it into to both the wallet logic, which we're not dealing with right now because obviously consensus rules come first, and then to bring it into Zcashd. But the actual pieces that do the parsing and so on are there. And we worked out a while back how it's going to flow into the RPCs for Zcashd. And so for most people, like miners in particular, they shouldn't really need to do much to migrate over. Like it'd be if a mining pool who's currently doing shielded Coinbase wants to migrate over, they would probably be the highest touch point of anyone on that side. I think everyone else is just, if they're using the existing RPCs, it should just flow through as far as transaction creation goes. Obviously, as we have documented some of our tickets, the way in which we're going to handle balance in Zcashd, we're going to add new APIs for this because it's too complex really to overload the concepts in the existing like zget total balance and things. They weren't quite designed for the right semantics. So we've got some new outlined APIs in the relevant issues that they just make it easier to reason about what the balances within the UAs are actually doing.
Right. Yeah, it wound up being, as most things are, a little more involved when you got to the details. Yeah, just a little bit, right? It sounds pretty straightforward on paper, and I guess conceptually it is, but then when you get to looking at, as Strad was mentioning, RPCs that have always dealt with, like, they were based on an individual address for the most part, and then it's like, oh, well, this actually now is multiple addresses. So how do you handle balances or viewing keys or things of that nature? So, all right, yeah, the last mile, as Nate says, is always the longest, I think. But anyway, yeah, so that's kind of the general update. More than happy to talk about any of the specific progress we're making on the implementations. The circuit work is coming along really well. It's also really complicated, the code. And but the team is, I kind of gave a shout out at the beginning to Zcon 2 and everyone involved there. The team is incredibly impressive. One at I thank them and apologize simultaneously on Monday morning calls because it's and most every day of the week actually, but it's just impressive the level of effort that's going into this, and not only just cranking out code, but attention to detail, which is quite honestly of utmost importance. This isn't a SaaS platform we're launching. You don't get a do-over. You don't get a point release necessarily the next day. You really can't afford to make mistakes. Obviously, if there is one, you can deal with it. I'm sure the team's well versed in doing that, but just the precision at which they're executing and the amount of work getting done and the quality of work is super impressive. They're all working incredibly hard. So hats off to the folks, both at ECC and the foundation engineers who are just cranking away like crazy on this. So it's a great effort.
Especially our most recent engineers in core team, Yingtong Lai and Chris Nutticum. Really stepped up to the plate.
Oh yeah, Yingtong has, and we've got to have a special Arborist call for Rory and Yingtong one day because Yingtong's in Singapore. It's middle of the night, so we need to do one way earlier in the day where they can both attend. But Yingtong has done just a tremendous amount of the circuit work itself, and some very impressive refactorings and design. So just incredible work there. And Chris has done a tremendous job just implementing like the zips on the prior page. Like you could put Chris's name by a number of those specifically. Not that it's not a team effort, of course, but there's usually someone on point to get a zip implemented, and Chris has done an incredible job there getting that. And Larry, I'm not sure if Larry's with us. Larry Woon does double duty on wallet team and core. And Larry's helping us on the Zcashd side. He's incredible expert in C++ and the Bitcoin code base. And so he's just a great asset to have on the team as we're looking to do things like the consensus rules on the Zcashd side and the RPCs. So.
We can't stop and not mention Strad because
Mhm.
he is the one who keeps the entire protocol from the circuits through the consensus rules through the C++ code base in his head at all times.
Yes.
And it is impossible what he does.
It really is.
Clone him.
Strat agrees.
I love it.
But no, it's yeah. So top to bottom.
I can't keep the C++ stuff in my head. I can keep the rest in my head, but not the C++ stuff.
Yeah. Now, Dara, Sean, the entire team has done just an excellent job and continues to do so. So we're, I say all that, one, to say publicly thanks. I thank them internally all the time. But then two, just, the diligence they're applying to this is going to pay dividends. It'll be a great network upgrade, very safe and secure and very solid. And that's what we're driving for at the end of the day.
We're rooting for you. We're using your proof code. Pertaining to that output. So the KEDIT and the NCC audits have started on implementation, and the circuit is still being finalized. So that will be covered by the KEDIT audit.
Yes. So we're kind of chasing the audits a little bit. Like we've given them, they have plenty to work on at the moment, but we're working with them to get the circuit code, in a final state for them to focus on the latter part. But yes, that's KEDIT in particular on that.
Cool.
If we have to, by the way, we're not opposed to extending those audits in some fashion, or even bringing in a third party, or an additional party, I should say. The main thing is when they're wrapped up, I want, everyone wants to feel really good that everything was covered adequately. And that's the main driver. So we're flexible and willing to extend their audit periods, bring in another party if we needed to, if they didn't have the time. It may not be necessary, but to be determined. If it is, then we want to make sure everything's reviewed well. That's the driver.
Awesome.
If you're paying attention to the difference between this timeline and what it was on the last call, we've actually slipped 2 weeks, and that's partly just the more accurate estimation of the time needed to finish the section.
Yeah.
Got it.
Yeah, it's a lot of work. Just quite honestly, it's a ton of work, and so you do your best estimating and you kind of go with that. But
it's fair to say that these ultra-plonk style circuits are significantly more interesting, shall we say, to get right than the old R1CS bucket.
Can you give me a taste of why? Because I don't have an intuition yet on why.
Yes. I can. There are just more degrees of freedom in how to optimize. So I mean, you could write a Plonk circuit that was equivalent to an R1CS circuit, and that would be about the same complexity. But if you actually want to use the lookup arguments, the custom gates, if you want to do packing of the circuit efficiently, then that's where the complexity comes in. And also partly because this is the first time we've done this, and we're making up the tools as we go along as well as the actual circuit.
Yeah. Makes sense.
Well, I mean, the circuit is documented, but
on that note, if anyone on the call is like really good at web or really good at like building like UIs for things and would like to like have a chat about building interactive circuit viewer, get in touch with me, because like I have a thing I have wanted for building this for ages, but I do not have the graphical ability to build it.
So all I know is it's going to involve D3.js somehow.
that is a name that rings in my memory
Oh, yeah.
of things I have
Mhm.
tried and failed to use.
Not it. I'm calling not it.
Not it. Yeah. There you go.
Yeah.
Nate, you had a hand up.
Yes. So I wanted to ask the foundation dev team how much like awareness or coverage do they or insight do they have into the new circuit code?
Well, I'm
design?
watching all these PRs fly by on Halo 2
Yeah.
and Orchard. And I see that there are, little chips and cores. I don't know if they're still being called cores, but there are chips.
Cores are no more. Cores
Okay.
are a dead abstraction.
All right. So I see
Way
them
to go.
going into the Halo 2 crate, and I'm like, cool, that is a thing that you have to you have to write a circuit, an arithmetic circuit from scratch in order to do the thing inside your arithmetic proof, your arithmetic circuit proof. And it's like, oh wow, that's a lot of work. I'm gonna stay outside of the proof.
Yeah.
So
Well, I mean, if someone's interested, we could, at some point give a quick overview of like how one of these smaller pieces works.
Yes.
I mean, what do we have? We have like an hour left in the call. So if we have some time at the end, I'd be happy to
All right,
pull one
yeah,
up
we'll
and-
see. We'll get to the rest of the schedule and then
Yeah.
we'll see if we have time.
Yep.
But yeah.
yeah, I
Does
was
that
going to
help?
jump in.
Yeah.
Mhm.
Yeah,
Go ahead,
that's helpful. I was basically Strad preempted me, but I was wondering if maybe even we could use. I don't want to sign people up for extra work, but if we could use like multiple sessions, so I would be interested in like a session that focuses on the circuit building tool chain with like some example circuits, and then a different session that's like an overview of the Orchard circuit.
So we were doing some like internal and semi-external Hello study clubs as we were sort of earlier on going through things. But yeah, we could set up something similar to that. Certainly, it's a lot easier to explain it now that we're at this end of the of the pipe.
You can imagine. Yeah, I'd be down to just grok more what's going on inside the circuit.
Isn't the SHA-256 gadget, isn't that kind of an example?
Yes, but it's probably bit rotted a bit because it's a very large example. It was very useful for figuring out like how to figuring out the APIs we wanted to build more complex things. But it's not on our critical path, thank God. So so yeah, no, we have much better examples in the Orchard circuit to go over.
I mean, the SHA-256 chip is a really good example of how to use lookup arguments effectively. But I guess we also have system A for that.
Yeah, my point being that the SHA-256 is actually out of date at the moment. It needs updating to the current way that we build chips.
Okay. All right. Well, actually, that's all the prepared slides. Yeah, that was it. Just kind of an update on NU5 since we didn't have any specific topics. I can stop sharing. We can just continue the discussion or talk about whatever anyone would like to.
I will note just to re-up that we are strictly blocked on verifying Halo 2 proofs until you guys do finish that ability. We are strictly dependent on that. So I put my async blah thingy to the side until we can get that to verify specifically Orchard action proofs in Halo 2, not any Halo 2. We don't care about the others. We care about one very specific thing that we're proving. So that we're strictly blocked on that, but we have plenty of work to work on until those are available. That's it.
Yeah,
cool.
We have the.
Sorry. Go ahead, Strad.
I was just on that point. We have that's going to be pretty well encapsulated, both because we want it to be so as well for ease of use in our logic. So at the moment, if I want to benchmark it, I have to make a bunch of things public, but I don't want that to be the case, and it won't be.
Okay.
All right.
Do we have any interesting benchmark results?
Let's get Tayor's hands up before we do that.
Sorry,
yeah. We might have some good benchmarks. Yeah.
I was actually wanting to ask about the network protocol. So if we wanted to finish talking about proofs first,
Oh, okay.
I'm happy to do that.
Yeah. So I have, actually, I can probably even pull up. I've got them sitting around here somewhere. Pull up another thing so I can get explorer.exe. Hopefully it's the right one. Do I have it even
Are
in
these
here?
the flame graphs or?
I was about to pull those up, and I'm in the wrong folder. That's what the problem is. Just a moment. Zcash, Orchard, target, criterion. It is not there. I will go pull it up from wherever else I threw it. I threw them into our channel, so I can just go get them from there.
Are these after you made those optimizations?
No, I don't. For some reason, those have disappeared. I obviously cleaned them, so I will just. This is just the unoptimized one, but it gives you an idea of the stuff that's going on internally. Cool. Share screen. I want that one. Share. Yeah, that's the Halo 2 prover. And the pink bars are some unnecessary work that's going on improving. So this is the trace of what's going on when it's doing a bunch of things it doesn't need to be doing. Just basic computing constants that it needs to do that at keygen time, and it was accidentally doing it during proving time. So we've got some small optimizations I'm about to make to the circuit that basically cut that time in half. And yeah, you can see the if you ignore the purple sections, you've got the chunks in here, for instance, that are doing circuit synthesis, and a bit down here. And then you have this lovely section in here, which is off separate because of the threading, which is doing your FFTs and multi-exp and stuff at the end of the proof. And at the moment, sort of the rough benchmark we're seeing is about 4 seconds.
So 4 seconds for the whole action proof.
Yes.
Proving.
And that's equivalent to 2 spends and 2 outputs.
Cool.
Sorry. No, 1 spend, 1 output. Sorry, I got them the wrong way around. I was like, it's like, no, it's not like, it's the wrong comparison to Sprout. So it's so at the moment there's more that we can potentially do to squeeze some. I mean, Sean can speak to that a bit more, but at the moment, without too much heavy optimization of the prover itself, we're not seeing it being too much slower than to work on than Sapling.
How much for just the FFTs?
I don't have those offhand, but at least that section of it makes up about 65-70%, I think, maybe more. There's definitely more stuff going on in synthesis that we can trim down. So I would expect to see these drop another, probably at least another third to half of a second from improving synthesis. Because also there's stuff like there's a lot of logic that the synthesizer goes through, which you could technically cache once you fix the circuit, like laying out, for instance, the way that the circuit is set up now. We use a laying out process that does it actually synthesizes twice. It goes once through and measures all the pieces that go into the circuit. Then it lays them out in an optimal fashion to which actually I don't know if people have seen this one, but if I can pull it back.
That was a question, Strad, while you're there. What are the axes on this graph? Like,
this is a flame graph. So upwards is deeper into the code. So horizontal is just like percentage of time spent in that part of the code, and it's just back traces going vertically. Right. So like in here stack. Somewhere is it's the call stacks. Like in here is prover, create proof. It gets a little bit messy because the perf library doesn't always collect the exact right
Yeah.
backtrace. So this piece here is almost identical to this piece here, but one of them is missing this one has an underscore start and this one didn't. So they're all off by one. So otherwise these two sections should really be merged
One
together.
big,
And
yeah.
I don't have enough time to figure out how to figure out how to get it to behave properly in that respect.
Yeah, there's an intermediate output used in generating the flame graph, and it's just a text file, so you can filter it and fix any.
When I have time and the circuits are close to actually getting in, then I can futz with that. This was just okay. Figure out what are the low hanging fruit we can get to.
Right, the hotspots.
And they were extremely useful for that because that's how we spotted that these constants were being recomputed every time.
Yeah. But if I just pull up the other photo I have, which would be neat, I think, for people to look at. I might have shared this on Twitter. I can't remember. But this is roughly what, at the moment, the Orchard circuit looks like.
Yes, that's what I wanted to see too. Yeah, that's awesome.
Yeah. And actually, I've got a couple of different variants here that show what the layouter was doing. Because if I go back to here, so
did we figure out why those regions, the darker regions, were being multiply assigned?
That's what we've been doing. So like that's part of the review process. So, but to just take a point on this, like the initial laying out process, like this would be what the circuit would look like if we just laid it out directly in order of business logic, like the order in which we call, like we do like IVK is GD times PKD and then go on from there directly in order and just lay things out row by row. And so then, this obviously leaves a lot of gaps in between. And so, if I go to like, which one here? So like in this process here, I just figure out all the regions and then sort them by their area, like quote unquote area, like the number of columns they take up times the number of rows. The idea being that then you lay out the largest pieces of the puzzle first within your area. And then where they don't line up, they leave larger gaps, which are easier to fill with smaller pieces.
So this is circuit Tetris, essentially.
Yeah, basically. Yeah, and deterministic circuit Tetris.
So if you look at the algorithm, it's exactly sort of slotting things into place like playing that, right?
Yeah, and so when we get to the end of it, we end up with this is roughly what it looks like at the moment.
Very nice. Nate?
So I don't have much expertise on hardware, but this feels like the kind of thing hardware synthesis does. Do we? Have we talked to folks who do that?
So hardware synthesis has another constraint that we don't have here. So in a Planck circuit, we can kind of magically make connections between far apart places in the circuit. We can do copy constraints. And so in a hardware circuit, you have to connect everything with wires if you want it to be connected, so that we don't have that constraint here.
Yeah, so I'm still curious though. I wonder if there's any hardware people floating around.
There are definitely parallels. There are also parallels to just like actually compilers like LLVM. If you think of it like being a compiler where not only can you optimize your code, but you can optimize the target. So instead of being like, oh, you have a CPU with a fixed number of registers, like, well, do you want 17 registers? You can have them. But
it's, if you go back one, so those two columns on the right side of the image.
These two here.
Yep. So why did they end up over there and not like, 5 columns to the left?
The horizontal columns don't the horizontal columns don't have a defined ordering. It's literally just the order that they got allocated during configuration. Okay. So rows are adjacent to each other. They have they have a linearity. Columns don't, and the reason that is because each column is a polynomial. So rows correspond to successive degrees of the polynomial, whereas horizontally they're completely it's a bucket. The assignment order here is just like a particular deterministic ordering that I was at, that I can get out of the prover, but it doesn't have meaning. So for instance, if I go to the one that is here, has slightly more fidelity, it's going to complain a bit, but yeah, if I zoom in this, here we go. So I can zoom in on the significantly higher one. You'll see here, this is, so this column here is fixed base model of spend-auth G. This section here is also fixed base model of spend-auth G. So this is all one region. I've just split, it's just showing up as split into several regions because there's like some other column that happened to get laid out in this rendering in between. But these here are the same actual laid out region, and they get laid out together in the layouter. And so yeah, so it's like this ties into the advice columns over here. Meanwhile, this big ass long column here is your Sensimia generator table.
Oh yeah.
The other interesting point here is that the layout of fixed columns, so these are the ones on the right in
blue,
the purple background, that matters less than the layout of advice columns, which are the ones on the left with the the khaki green kind of thing, because the advice columns affect the proof size more, so they're more worth optimizing effectively.
Yeah.
So a little bit of an oversimplification, but basically that.
Yeah, there are things we can do in there, and like a lot of actually the space here, this particular version of the renderer doesn't show it, but a lot of the space to the right here is actually just selectors. So the entire column is just Boolean values toggling bits of the circuit on or off. These larger chunks of regions on the left-hand side, that's really where most of the fixed values like round constants or generated generated tables and things end up going. But yeah.
And those basically are like they're pre-generated at some point before you start doing the proving. They just have to get quote unquote loaded into its register in the circuit before you can use it. Yeah.
So the way that we do this, you can either when you define a region, you then have the ability to assign cells within that region.
Yep.
And so a region is like this logical chunk across here through to here, through to here, through to here. And then within that region, any cells you assign maintain their relative offset, which you need for the constraints within that region to work. And so if you're doing something where you just need a fixed column and line, so for example, Poseidon, a round of Poseidon, you need a different round constant per row, but the way in which it interacts with your other variables is always the same. So we have a single like full Poseidon round, which just requires a couple of columns over where, I don't know where they are in here, but it requires like 3 columns for round constants in full rows, and then needs 6 fixed columns for partial rows, because we do 2 partial rounds per row. So we need twice as many round constants. But those all get just aligned and allocated at the same time as we do them over here. And then you have, you can also allocate static fixed things that you just need them to exist in a fixed location. And so that's like the orchard, the Sensimia table here. We just at the start of synthesis, you just go, I need to load this table in, and it will just make a region, plonk it in, and then the layouter will put it in a place where it makes sense.
Yeah.
Yep. And so
this is wild. And then how is this like a Rusty sort of thing where you can render things as like like layers of the stack are executed or something like that, or frames of the stack? Like, how do you render this, basically? How did you plug this into your code?
How do I render this particular picture, you mean?
Yeah.
Yeah, I can pull up the, let me just pull up my browser, not browser, the code, get to the right place.
And then I want to make sure I don't eat up all the time to talk about network stuff.
Yes. So yes, we'll put a time box of another like 5 minutes on this,
cool.
And then we'll move on. But if I just quickly screen share the...
I mean, if we want to talk about circuit optimization, I can do that for 5 minutes if you want.
Yeah, but yes, if I just quickly pull up the layout file. So all I'm doing here, so the way if you're familiar with Bellman and you know how it has that constraint system trait.
Sure.
Okay, so Bellman has a constraint system trait where basically the idea is that you implement your circuit logic, your like R1CS arithmetic circuit, and you set it up in such a way that you are you're allocating an R1CS constraint and then assigning variables and things all at the same time, and then that just gets thrown into a backend, and the backend can be whatever you want. And so it could be at keygen time when you're doing the circuit setup, or it can be proving, or it could be anything else. We have a similar thing in Halo 2. And so it's this, where is it down here? It's this assignment trait. And so I just implement assignment for this layout struct. And so every time, this basically has like hooks for every action that the higher level circuit synthesis logic does. So like when we enter a region, this gets called. And so I can mark that we're inside a particular region, and then the exit gets called. So that's sort of like, pushing onto a region stack or whatever. And there's similar, like there's name spacing pieces we can do, which I'm not using in this at the moment. And then every time we like assign advice gets called, I just remember that cell got in that particular location got assigned. And then once I collect all that up, I just, like each region, I collect what columns got involved in it and how many rows it took up, what cells got used so that I can shade them in, like specifically within the region. And then, just collect all that up in a layout function somewhere, and then do some very basic rendering just to literally draw on a surface and just like draw a rectangle that's white and red and blue and just put some pieces in to give them a shape. But the information this collects could just be shipped out to JSON.
Yeah.
Like, we don't have a format for it yet, but you could easily write an adapter to do that, and then ship it to a nicer interface that like had like click on a cell and it shows all the gates that it interacts with, or any remote cells that gets copy constrained in. There are so many wonderful things I would like to do, but I do not have the skills to do that. That's that front end side of.
That is so awesome. Thanks for showing that.
Yeah.
It's incredible. No, this has been incredibly valuable for a lot of reasons, but
I really appreciate visualizations like that. It really helps just make my brain absorb visually information.
Getting the right abstraction helps, and then it also means you essentially can sit there with your electron microscope or Microsoft Photos and inspect the quality of your circuit.
All right, Tior, you've patiently had your hand up.
Sorry. I should put that down.
It's okay.
At least I don't have to hold it up here that whole time.
Right, exactly.
So I want to switch gears to talk about the network protocol, which I guess is literally the entire other end of the stack. But I'm sure Strad will answer questions on it still. So we were chatting in the R&D Discord about the hash block commitments field in the block header, and how it actually consists of a series of hashes that are hashed together. The history tree, root, which we were talking about earlier, and the authorizing data root for non-malleable transaction IDs. In Zebra, we do validation in a very specific order where we leave any dependencies between blocks to what we call the state, where we have all the blocks in order. And before then, we just validate things inside blocks, because that's how we manage to parallelize so much of the validation, is that we are validating a whole bunch of blocks in parallel, and then we line them up and we do the history, and we make sure that they're all in the correct order, and check the parent block hash and all those kind of things that you need multiple blocks for. So anyway, that means that we have to delay the hash block commitments to validating that till quite late in the process, which means we can't bind the authorizing data in transactions to the block header until quite late in the process. And so one of the ways we can get around that is by just sticking these extra fields on the end of all the blocks in network messages, because Bitcoin has this thing where you could just add extra data to the end of network messages and nobody should care. I don't know how much we've exercised that functionality, but nobody should care if we do that. So I was just wondering.
We would normally add a new network protocol version for that anyway.
Well, you have to do that. But there is evidence in the historic network stack of our code that this has been done upstream several times before. In particular, in the version handshake messages, where you see like it does the thing where if it's not empty, add a bit, parse a bit more, and
yeah. So I was just wondering where we want to schedule that work. I would like to do it at some point because it is really useful for Zebra to be able to make sure we aren't just getting arbitrary garbage authorization data pretty early on in the process. But for us, we're really focused on just trying to get basic validation done. So we wouldn't mind if you wanted to leave that work to, say, a network protocol upgrade we might want to do after NU5, but we also wouldn't mind if you wanted to do that earlier on. So I guess it's just more of a question of scheduling for us.
I think, so the next step is to specify it in a zip, and that's the next step regardless of when we do it. So, yeah.
Yeah. No, I'm +1 on the idea, and from Zcashd's perspective, we don't have a need for it because for two reasons. One, headers are always downloaded in height order. We never have headers that don't know about their parents. And then we do not try and connect a block unless we have connected all of its parents, which means that when a block comes in, the block data comes in, it gets saved to disk. But if I recall correctly, no validation of it actually happens until it tries to pass through the process new block needle. Specifically, if we download it, but we don't have all the block data for the parents, so there's no chance to connect to the tip, we pop it into an orphan blocks area and just sort of leave it to the side and don't do anything with it. So in that sense, because we delay verification of blocks until they're actually getting connected to the tip, it does make it serial, but it means that then we can just do all those things in line. So it's not a requirement for us. And so I'm inclined to say that we definitely need to focus on getting the consensus rules out first, and then I'm inclined to think that we're more likely to be working on the third-party integration more so than that.
But I mean, there's no problem with Zcashd cooperating with Zebra in terms of sending that data regardless of whether it needs it.
Yeah,
we will eventually want to optimize this.
Yeah. Like the actual data, the actual change to the code will be very small compared to pretty much any other network change we could make. So yeah, if you want to write that up and have a zip for that, yeah, we can scope it when that's there. But yeah, it's certainly going to be lower down on our list of things unless we can establish that like the actual change to just spit the data out. Like if the minimal change for us is just spit the data out so others can see it, and then we just ignore it on the way in, that's probably feasible to slip in somewhere.
I mean, it's lower priority for us because it's not a required consensus rule, and so we're only doing required consensus rules.
Yeah, and if I understand the way that your validation works, it's really just shuffling around how you connect the futures, right? Like how you build the service tree in a way. So like if you wanted to move something that was, once you gained that data, you could just move the bit that does like the auth validation further across to the non-contextual part rather than the contextual part.
Yeah. So what it would mean is, it would be where we do the auth validation, but we'd probably have to, we would probably end up doing it twice, or just passing the previous auth route that we'd calculated along, just to make sure that everything matched up. But yes, it's an extra validation step for us that would be useful, but it's certainly not something that we're required to do. So yeah, happy to leave it a few months if that works better on your schedule.
Yeah, we're not short for work on this side.
Neither are we.
But I'm happy to review the zip whenever it comes.
Yeah, sure. Okay. I will open a ticket and we'll schedule it when we think it's important enough to do.
Yeah, very good. Nate, you had your hand up.
Yeah, I was just more context about that discussion. So can I just see if I got a summary correct? There is some kind of optimization or improvement Zebra is doing with validation that might be related to batching that imposes this issue where some of the data is not available locally to do transaction validation earlier in the process?
It's a little related to batching, but it's more about trying to separate the pieces of validation that can be separated from a full chain state, and doing them as early as possible. So we call them structural, semantic, and contextual validation. And contextual is the one that requires like the full knowledge of the chain state beyond the reorg limit. So with the new auth tags, it requires more information about the chain state that we previously were able to, without that change, we're able to previously validate it without context, like block header kind of independent of, header stuff independent of the full chain state. And now we need more chain state. And so it makes shuffling that around a little more difficult. And if we add this information in the messages, we're able, it works better for the way that we're already kind of piecing out all of these pieces of validation. It's a thing that Zcashd does not have to worry about, and ZebraD does. And yeah.
I mean, if we'd known about this when we were originally designing the block format change for hash data commitments, we might have, that might have pushed us towards changing the block format rather than trying to shoehorn it into an existing field. But yeah, it's too late to do that change now. And we don't.
To be clear, the issue is that we can't bind all of the bytes in the block to the block header. So previously we could, because transaction IDs were a hash of all of the bytes in the transaction. Now we can't bind those bytes. So it impacts how we implement both our checkpointing and how we implement our the rest of our verification. It just means we need to maintain the block history even while we're checkpointing, because we have to bind all of those bytes in the block to the block header.
Oh, I have okay. I think I get that. I have another question and a comment.
No, hang on. Can I respond to that? Why are the bytes of the transaction significant? Because one of the points of this change in NU5 was that the bytes of the transaction would no longer be consensus critical.
When Zebra does checkpointing, we check that all of the hashes of the block header hashes, we check that they all line up in order between two hashes that are very early on in the chain, well before any rollback. And so previously we could bind the contents of the transactions to the block header, and then we could bind the block headers to the checkpoints, and we know that all the bytes were correct. Now we also have to validate the block commitment, because otherwise you could change bytes in the authorizing data, they wouldn't be bound to the block header. And so you could put garbage in those bytes. And so you get a different result between checkpointing and full validation. And that's not ideal. In fact, that's a security issue.
Right. Okay. But it's not actually the bytes of the transaction that matter. It's whether the authorization data is valid.
Yeah, it's
yes.
Yeah, the data dependency that didn't exist before is that the chain history root can't be computed without knowing all of the prior history. And the hash block commitments is a hash of the auth data root, which can be computed just from a single block, and the chain history root, which requires all history. So you need the side channel information to validate a block on its own. You need to provide chain history root. And previously that was provided in the block header field, and now it's not.
So there's almost should have been separate fields if we thought about it differently. But it's okay.
I mean, the preferred one, if we'd been able to just like change the block header entirely, would have just been to replace the hash reserved field with a vector of commitments, and then but we had enough going on, and changing the block header is not really a change that we had the bandwidth or energy to take on in this cycle.
Yeah,
I mean, effectively,
is going to be fine.
Effectively, that's what Zebra will do. We'll add some fields to our block header once this change is in, and we'll pretend that the block header has those extra fields in.
Yeah.
And that'll be it.
Yeah. And then in future, when we eventually do make a block header change, we can just make that change and make those part of the header.
So question, Taylor, Walter asked, you mentioned when Zebra was checkpointing. So Walter asked, checkpointing what exactly? Just if you could explain that a little bit.
So Zebra has two ways of validating blocks. We can either run all of the consensus rules on the blocks, or we can provide a list of block hashes. Every, I think it's 400 blocks or so, we put down a height and a block hash. And then when Zebra goes to sync, it will line up all the blocks in that 400 block interval. It'll make sure that all of their parent block hashes match up, and it'll make sure that the hashes at both ends match up. And as long as all the data in the block depends on, as long as any change to any data in the block would change the block header, then we know that it is safe to just check those hashes rather than running full validation on every block. So we are doing that in order to save CPU time when the set of blocks is fixed way back for basically previous network upgrades, because we know that those blocks are fixed.
Okay, all right, thank you. Nate.
I had a, let's see, question. Oh, okay, so then it sounded like there was this proposal to extend the networking protocol to facilitate the code architecture of Zebra, right? Is that what the zip people were talking about was?
Yeah, so to facilitate parallel verification or to make checkpointing easier, those just happen to be features that Zebra has implemented, but any node implementation could implement those features.
Right, that makes sense. So, oh no, new fingers keep popping up. So one question I had would be, it sounded like there was this other alternative that is a bigger scope or harder to do, which would be modify the header commitment scheme to facilitate a similar outcome. So if that's true, I was curious how that compares to changing the network protocol.
It achieves the same effect. It's just a little bit simpler and more direct way of doing it.
Which way is more direct?
Putting the having a vector of commitments in the block header.
So
rather than having where my out of band.
Where my mind goes is, if we could do that header change like in the next upgrade, is doing a network change worth it? Or is that too long to wait? Or I don't know. I'm just curious.
I think the network
those approaches
is worth it. because we can do that in a couple of months.
Yeah. Once we have the
whereas-
bandwidth for it, it's simple to do.
Yeah. Whereas
And
NU6
then-
will be next year.
Yeah. And if we then later decide and then do make the header change, well, then we're paying a single byte extra cost on the network, because if you just send it as a VEC, and then you stop putting commitments in it, it's just a single byte of 0. So
Okay, got it. The final thing was just the comment that I'm really nervous about hidden or implicit consensus behavior in the Zcashd networking stack, or the wallet stack. So anytime I hear about changing the networking stack, or changing the order or sequencing of validation, I get nervous. And so I'm really glad that we have this Zebra implementation showing up. So hopefully, if there were anything hiding there, we can discover it. But the biggest fear is that there would be something that we don't discover until everything's running on the network and there's a live issue. But that's just a comment. Yeah.
It
And
sucks
also-
to have consensus critical rules that are not documented or well understood by anyone who's working on
Yeah.
that.
Yeah, so if you have rules that are not included in the protocol spec, even if they're kind of Bitcoin specific rules, then just tell me about them or file an issue, because I do want to add those. The only reason they're not added already is the amount of work involved.
Yeah, can we just, would it make sense to just make a label or a category for ambiguous thing that's probably should be in a Bitcoin layer spec that we don't have spec'd yet, just to start tracking anytime we notice something that could be there?
Just
Create
add
an
the
issue.
protocol spec label.
To an issue, yeah.
Yeah, I think for us in Zebra, we're well aware of a lot of network protocol rules that are quite vague, particularly because we've been reviewing our network stack and working with the Zcash team on security issues, and the Zcash team themselves have come up and said, look, the network stacks are very different. And that was kind of the idea of writing Zebra, is if you want parallel verification, you have to have a parallel network stack. So yeah, I guess we'd like to do that work after NU5 when we're already changing the network protocol, and just make specification part of the work that we do there, so that any new changes to the network protocol get specified, and then anything that's sort of context for that also gets specified.
Yep.
Yep. And certainly that's been what we've been doing with like upstream network protocol BIPs that get backported. We've just imported those BIPs as appropriate.
All right. There's one question in the chat from way back. I just saw it. Aditya asks, how's payment disclosure support for Sapling and Orchard Pool? How's it coming up, or when is it coming up?
There's not been too much movement on the zip itself recently. I think I have a in progress branch somewhere. All of that stuff has been put to the side because my head is full of chips, wood or otherwise. And so, but the design for it is pretty solid for Sapling, and it wouldn't take too much more work to extend that to Orchard. I think the biggest thing that's missing is serialization, because serialization is a hard problem. I would argue harder than writing circuits.
I would dispute that. It's just passing and printing. It's fine.
Yeah, but people have opinions.
Yeah, well, people will have opinions on circuits when there are enough people.
Yeah, but there aren't yet, so we get to have the opinions.
Yeah, and we get to design the APIs and the abstractions so that we can shape and mold their opinions.
Yeah, but yeah, that's really the like. I mean, really, I think if we could just define something that was like a, you know, if I were to lean on the, well, we do everything in Rust, so then it would be define some sort of structure for storing these things in, and then give it to Serday, and then people can just encode it however they want. And maybe we just pick a default like bin code or something as the thing that we use by default in tooling. Like I've not done enough with Serday to sort of know exactly how much of a penalty it is at compile time. I hear it's like it can be bad, but that seems like the way to put that problem off. And everything else about the design is pretty straightforward. The one bit that is missing at the moment is, I think is it BIP 322? I'm remembering from upstream. There was an upstream PR upstream BIP to do with like modernizing how Bitcoin signatures are done, like signing messages. And so there was some adaptation from that.
Yes, generic sign message format. Yes.
Yeah.
We want that actually.
Yeah, basically to adapt that to handle effectively the ability to do payment disclosures, where like we want payment disclosures to sign, like all of the inputs to the transactions sign it, which means having transparent inputs to transactions be part of those signatures, so that the payment disclosures are like fully authorized, bound and non-malleable in that regard. But yeah, there's draft zip. I can drop it into there if people want to comment on it. It's sitting there ready for people to look over. Here we go. It currently is Sapling payment disclosures, but you can assume it will just become like payment disclosures for Sapling and Orchard and similar.
Cool.
Okay. All right, we are basically right on time. I think that was all the questions from the chat, all the hands. So next time, 2 weeks from today, we'll have, again, Ziggurat is going to come do a presentation for us. We'll obviously continue to have updates on NU5, and then anything else anyone would like to cover. It's 2 weeks from today, Walter. Yeah, we do them every 2 weeks now.
Awesome.
All right. Anything else? Nope. All right. Everyone have a good rest of the day, good weekend, and we'll catch up in Discord.
Bye.
Right.
See
Take
you all.
care.
Thanks.
Bye.
Cheerio.